Hope I am audible. Okay, 58 students have joined. I guess some more people have to join. I think, what is the class strength? 73 or 74? Um, yeah, it is 74. I think another 15 members they have to join. So shall we wait for another 1 or 2 minutes or we'll start? Hope all of you are fine and your family members are also fine and people have come back with a lot of energy and enthusiasm. Okay, guys, good afternoon once again. As you all know, I'll be taking electromagnetic waves for this semester. Hope some of you are familiar with the subject, what exactly is the subject, and it deals with what type of concepts or the fundamentals. So, as the name itself says, electromagnetic waves. Electromagnetic is a wave which composed of both electric as well as magnetic field components. Okay, so this is a kind of fundamental subject I can say in order to understand other subjects like communication, where some sort of signals are propagating or transferring from one end to the other end. At the same time, you have studied network theory and analog electronic circuits, right? So when you have studied the network theory or analog electronic circuits, you have basically come across voltage and the current. So when I talk about current is what? It is nothing but the flow of charges. So when the charges are at rest, they are generating a kind of field, and that field is known as an electric field. And when these charges are moving or when they are in motion, then again they produce another kind of field which is known as magnetic field. So the combination of this electric and magnetic field together has given the name as electromagnetic wave, since it is a kind of energy or a signal or a wave which is going from one end to the other end. So we have coined the name as electromagnetic waves. Okay. Since, as I told you, it's one of the fundamental subject to understand AEC network theory, where you are dealing with lot of current and voltage component, and coming to the advanced subjects like digital communication, analog, like you're going to study in PCS, principles of communication system, how the information is going from one end to the other end, or maybe ITC, where in ITC a lot of encryption, maybe algorithms you are learning how to secure a signal before you transfer from one place to the other. Similarly, when you learn other advanced subjects like microwave and antennas or optical fibers, again their electromagnetic waves are involved, because when we talk about microwave, it is basically the electromagnetic waves. Or when I talk about optical fiber, again light, where again light is a form of electromagnetic wave where both electric as well as magnetic field components are involved. Okay, so starting with this introduction, I want to take you through the syllabus of this particular subject, where all of them are aware that we have total around 5 modules, where again in each module it is divided into part A and part B. Similarly, the what to say, from the examination point of view, the question paper, see this time the video people, because of the uncertainty, they cancel the exam, but for the coming semester it's no way that they will cancel the exams. The exams are going to happen. We don't know whether the online classes will continue for another 3 to 4 months or maybe just for 1 month. We don't know the current scenario. As of now, we are supposed to take the online classes for the month of September, and from October I think the offline classes will start. but still I'm not sure. Based on the government decision and other situation, they might decide. In case if the online classes continues, so the classes will go on till December. And what I'm thinking that they might call the students in the month of January for some kind of crash course, and later they may conduct the exams. So there is no chances of exams are cancelled. Exams will be there whether we are teaching online or offline. Okay, now coming to the subject, as it's completely what to say, a kind of conceptual subject or a fundamental subject, a lot of fundamentals are involved with that. And since it's a numerical subject in the sense you must have studied LD or AC, where you have a set of theory, derivation, and then followed by a few numericals. But this subject is not at all like that. From the examination point of view, if I talk, maybe the question paper pattern, out of 100 marks, 80% are numericals. That is 70 to 80 marks are dedicated to the numericals, and the remaining 20 to 30 marks are dedicated to the numericals. You don't have any kind of theory here. You have one derivation. Based on the derivation, you have some set of numericals. And coming to the requirement in order to learn this particular subject is, the first requirement is you must be having the knowledge of mathematics. Mathematics again, like integration and differentiation. You have gone through various formulas when you're doing integration and differentiation. So similar way, you must have the basic knowledge of integration as well as differentiation. Clear? And then the third requirement is you must have the knowledge of vector calculus. So already you have studied in mathematics vector calculus, where you know how to represent quantity in terms of vector or a scalar. Similarly here the fields are a kind of quantity which we want to express either in scalar or vector. I can say when the charges are at rest, some kind of magnitude is associated with them. Okay, but when these charges are in motion, they are propagating in certain direction. So when we try to represent them, we usually take the help of this one vectors. That is scalar quantity and vector quantity, where along with the magnitude, some direction is also associated with that. Okay, so starting from integration and differentiation, you must also have a knowledge of vector calculus. Okay, and along with that, very pretty good knowledge of coordinate systems. I know most of you are familiar with Cartesian coordinate and polar coordinate. So I think we have around 9 to 10 coordinate system in general. But particularly here, you must have the knowledge of Cartesian coordinate, cylindrical coordinate, and spherical coordinate. So if you go through the syllabus, beginning itself, they have given the prerequisite or the requirement to learn this particular subject is a vector calculus. So you should know what is integration and differentiation. Then you must have the knowledge of vector calculus. What is a vector quantity? What is a scalar quantity? How are you going to represent them? What are the unit vectors associated with a particular direction when you try to represent them? And then followed by the coordinate systems. Then, as I told you, there are 9 to 10 coordinate system, and out of them, we are focusing only on three types of coordinate system. That is rectangle, cylindrical, and spherical. You might ask me the question, out of these 9 to 10, why only these three coordinate system we must know? The reason is that whenever we are using a rectangular or a Cartesian coordinate system, we usually try to represent the points. Yes or no? And one more thing, when I am talking about the coordinate system, it is not 2D, it is 3D coordinate system. So any electric field or magnetic field, we try to represent in terms of 3D, three-dimensional. So here we just don't have X and Y axis, we have X, Y, and Z axis. Okay, so when I'm talking about Cartesian coordinate, basically in Cartesian coordinate, we try to represent a point. Yes or no? One particular point, it is at certain distance from the X axis, Y axis, and one more axis involved here is Z axis. Clear? Similarly, cylindrical coordinate, where cylindrical coordinate, I can take the best example is the current flowing through a conductor. See, in Cartesian coordinate, what happens? As I told you, a point can be represented. I can just keep a point. I can say that particular point is at certain distance from X, Y, and Z axis. Clear? So why point? Because if I consider that one electron can be considered as a point charge. Okay. So if I want to represent one electron or one point charge, I can just try to locate in the Cartesian coordinate system. Similarly, cylindrical coordinate. Why cylindrical coordinate? As you all know, a current carried conductor is cylindrical in nature. Correct? So whenever we have a conductor and the current is passing through this, the charges are in motion, the charges are moving. So in that cases, when the charges are moving, of course there is some sort of electric and magnetic field is present around that. Okay, so in that case, we must have the knowledge of cylindrical coordinate system in order to calculate what are the electric fields and the magnetic field associated with this particular cylindrical system. Or maybe for that case, I can take the example of a coaxial cable. You have seen no cables in AC lab which you connected to the CRO and to the input and the output. What is that? It's a coaxial cable, correct? It is cylindrical in nature. Outside you have that rubber insulation, but inside you have a conductor. Okay, so it's also an example of a cylinder basically. So it is carrying current and some sort of electric and magnetic fields are present. So in order to calculate or determine them, I must have a good knowledge of cylindrical coordinate system, like how I keep the conductor and what is the distance from the x-axis, y-axis and z-axis. Okay, now coming to the spherical coordinate system, as you all know, spherical, maybe I can take the example of a globe or orange or something. It looks like a sphere, correct? And at the same time, people must have observed the dish antenna. All of you have dish antenna, right? On the terrace. So have you seen how it is? It is half cut. Maybe it is spherical in nature. So what happens whenever we use antennas? Antennas are basically used to transmit and to receive the information. Clear? So whenever these antennas are transmitting or receiving some sort of information, those information or those energy are nothing but electromagnetic waves. Clear? So whenever these antennas are generating or transmitting some set of electromagnetic waves, again I should know when they are trying to propagate the waves, what are the fields associated with those waves. Clear? So when I want to calculate what are the fields or the wave generated by the antenna, in what direction they are getting propagated, I should have a knowledge of spherical coordinates. Right? So the four requirements are: you should know or you should be familiar with integration and differentiation, followed by vector calculus, followed by the all the three coordinate system in 3D, that is in three-dimensional systems. Okay. Now I'm going to share you the syllabus, and in detail, maybe module wise we can go and discuss what are the topics we have, and later I'll show you what are the textbooks available, and the other things I can share, other details I will share. Hope people are able to see this the slides. So it's electromagnetic waves and the subject code is 18EC55. So the first module, as I told you, it covers the Coulomb's law and the electric field and flux density associated with all the point charges and the line charges. Before we could actually start the syllabus, we have this revision of vector calculus. So it's like a prerequisite in order to understand this particular subject. And I think I may need around 6 to 8 hours to cover up this vector calculus initial part before I could actually jump to the syllabus. So when I'm starting the classes, don't think that it is starting with Coulomb's law and ma'am is sitting and teaching Cartesian or cylindrical coordinate. As I told you, they are the prerequisite, and before we actually go to the syllabus, understanding those coordinate system and how you're going to represent them in the form of a vector is very, very essential. So the beginning 8 to 6 hours will be dedicated for this fundamental part, and then later I'll move on to the actual syllabus. Most of you are familiar with the Coulomb's law. You must have studied in physics or I guess in the physics of first year engineering. The same thing we're going to learn here. Only thing, everything will be represented in vector form. Okay. So the first module, it will cover the basics of vector calculus, followed by the Coulomb's law, the electric field, the electric flux density, and how the charges are distributed in a conductor, or maybe volume of charges, or maybe a line charge, sheet charge. Sheet charge in the sense, I can take the example of a capacitance and all that stuff. So the basics you're going to learn here, and the numericals with respect to these topics. Okay. So these topics are covered from chapter 2 of the textbook. And then we have module 2. Module 2, again, it is divided into part A and part B, where part A covers the basics of Gauss law and the divergence theorem, and basically how we are going to represent these losses in integral form or maybe in point form. Okay. And from these Gauss law and divergence theorem, we will be deriving the first Maxwell's equation, right? And then we have numericals based on these topics. And from the textbook, it is topic 3.2 to 3.7. And part B covers about the energy and the potential, and about the conductors, that is when the charges are moving or they are at rest, what type of energy is associated with them, or what is a field associated with them. And then we have good number of numericals on them. And then we have very important topic here, that is current and current density, followed by the continuity of current. So you must have studied this concept, no? Conservation of charges can neither be destroyed nor be created. So that, based on that law, you'll be learning about this continuity of current, and we have a small derivation here, and based on the derivation we have numericals, and that topic is covered from chapter 5. The topic is from 5.1 to 5.2. And then we'll move on to module 3, where module 3, again, it is divided into part A and part B, where in part A we have very, very important topic, which is Poisson's and Laplace equation. And of course we have a small derivation on this, followed by a very important theorem, that is a uniqueness theorem. And we have lot of numericals which are based on this Poisson's Laplace equation and uniqueness theorem. And from the textbook, it is chapter 7 from point 7.1 to 7.3. And part B, it covers the magnetic field. I'm sure people are familiar with Biot-Savart's law and Ampere's circuital law. You must have studied in physics. And then Stokes theorem. Stokes theorem, I think you have studied in mathematics. But of course, everything will be in the vector form, but it is related to the fields, the magnetic field. Okay. And then we have a small topic on magnetic flux and magnetic flux density, followed by the potentials, like how the potential is associated with the current or moving charges. Similarly, some sort of potential is present because of the magnetic field. About that you're going to learn. And then followed by the numerical. See, if you notice here, each and every topic, they have numericals associated with them. As I told you, the subject hardly covers 20 to 30% of derivations or maybe theorems. The remaining 70 to 80, it is completely numericals. And then module 4, again, it's classified into two parts. Part A, magnetic forces, where we're going to learn about the moving charges. That means, say, for example, if I have two conductors which are parallel to each other, and the current is flowing both the conductors, when the charges are moving, of course, it is creating some sort of field, magnetic field. Similarly, the other conductor is also creating some sort of magnetic field. So when the fields are generated by both the conductors, what kind of effect or impact they have on each other. Basically about that you're going to learn in this particular topic. And then we have numericals on those derivations. And part B, it covers about the magnetic materials, like the basics of what you mean by magnetization, what are the various I can say effect associated due to the magnetization, the permeability of the different media, the boundary conditions, okay, as well as the potentials associated with these magnetic materials. And we have numericals. And continue with this, we have an important topic, which is Faraday's law of electromagnetic induction. I think people are familiar with this particular law. So from this law, we'll be deriving one of the Maxwell's equation. And then finally, we have module 5, where again part A, we have Maxwell's equations, and part B, we have plane wave, propagation of the plane wave. So here in part A, we're going to represent the Maxwell's equation in four different forms. I mean, we have four important Maxwell's equations. Two of the Maxwell's equations are associated with the electric field. Another two of the Maxwell's equations are associated with the magnetic field. And how these four equations are related to each other and how we can express them either in the point form or differential form or integral form, that conversion we'll be learning in this particular chapter. Of course we have a few numericals here. And the last part, we have uniform plane waves, where basically we are going to derive here a lot of derivations, where we are going to say how the uniform plane waves are propagating, and when they are propagating, what kind of effect it is creating. That means I can say when a wave is propagating either through a free space, or maybe through a vacuum, or maybe through a conductor, or maybe through an insulator. Okay, so whether they are having some sort of losses or not, and what is the impedance associated with them, what is the wavelength, what is the frequency, all the stuff you're going to learn in this. And with that, you have a very important topic here, which is a Poynting theorem and wave power. That is, whenever electromagnetic wave is propagating, it is composed of some power. That power is because of the electric field and the magnetic field, or electric and magnetic potential. Okay, so what is the power associated with this electromagnetic wave, and how this power undergoes losses whenever the wave is trying to propagate through different medium. About that you're going to learn. And of course the numericals. Yeah, the numericals are very simple in this particular module, but the other all 4.5 modules, a lot of integration and differentiation is needed. Okay. And coming to the textbooks, the first textbook is William Head, which is the 8th edition. So the single textbook covers all the topics I have already shown you. It covers all the topics. And then the reference books are three. The first one is Elements of Electromagnetics, Matthew. See, in case if you want to buy a textbook, my advice is to go with the first one, because the first reference book, Matthew, it covers very good fundamental concepts of electromagnetic waves, but whatever topics are present, it is not according to the video syllabus. Maybe to have extra knowledge, you can refer that. But if you really want to go along with the video syllabus, go with the William Heath. Similarly, same thing happens with the second book, Electromagnetic Waves by Jordan. It's a good book. Of course, the concepts are covered clearly and nicely, but the problem is it is not according to the syllabus. And the third book, it is by Narayan Rao. People can refer that. The concepts are explained very simple, and it covers a lot of numericals. People can take that, but my advice is, really you want to have a very good book on electromagnetic wave, then go with the William Hay. Okay. It's my suggestion is that people might be sitting and expecting that madam will send the notes and all that stuff. That is all fine. Notes are there. I'll be sending it. But the thing is, if you have a textbook, is better. What according to my opinion. See what happens in a notes when I'm writing the notes. Maybe I'm doing cut short and then writing the notes. Yes. So whatever it is there in the notes, you're just reading and that you're filling in your head. Okay, this is the information, but there may be another important information there in the textbook which I might not have written in the notes. Maybe it is not related to the syllabus, but it's always better whenever you're learning a particular subject, you have some out of the box thinking. Okay, out of the box topics. So better go with the textbook. I think it is available on Amazon, around 350 to 400 is the cost of the book, William Hay. People can buy that. Of course, along with that, the notes will be given, and the notes will not be given initially. As I cover the first part, like first part we have prerequisite to vector calculus. Once I finish that part and the Coulomb's law and all that stuff, then I'll be sending you the PDF copy. Okay, because what happens, I have solved all the numericals in the notes. If I send you the notes initially, people will not solve in the class. So better you put effort from your side, try to work out, try to solve the problems, try to understand the subject, and then later if I send the notes, you can just cross refer and try to understand. Yeah, and now coming back to the assignment and the quiz, one point I want to make it clear. Last time, like everything happened. Everything happened in a hurry and people were not knowing how to teach, and we had a lot of confusion whether to give the marks or whether the exams are going to happen or not. A lot of confusions were there. So people just randomly, whatever assignments or I think the quiz they attempted, based on that they got the marks. But this time that is not going to happen. We are very clear. For the initial 1 month, the online classes are going to happen, and maybe if we get a permission from VTU, the offline classes will start. So once you come back to the college, no issue. But in case if the online classes continues for the entire semester, then we have to take a call. So since the subject is completely a mathematical oriented subject, so it's not like I'm sitting here and doing blah blah blah, and people other side I don't know whether they are listening, sleeping, whether they are there in front of the system. I don't have any idea. Correct? So what I want to do is, first of all, buy a new notebook for this particular subject. Don't have a single notebook where in the single notebook you scribble all the 6 subjects. Okay, I don't want that. So first of all of you must buy a new notebook, and then you must have a scientific calculator with you. Without Calci, you cannot sit in a single class because every time one topic, one derivation followed by numericals. Okay, so you must have the calculator with you in order to solve the problem. It is not like multiplication or division I can do it with a cell phone or something. It is not possible. As I told you, lot of integrations and differentiation is involved, and lot of angles, maybe in radian and other form, degree form. You need the calculator in order to have a conversion. Okay, so first of all, have a good notebook, one keep it aside, one single notebook, and then have a calculator. Okay, and then whatever I do in the class, take down everything. And one more important point, since your internal marks out of 40, 30 is for the test T1, T2, T3, and the remaining 10 it is for the assignment and the quiz. Okay, so of course assignment I'll be sharing some numericals where people have to solve and upload. But apart from that, for the quiz, I'll not be taking any quiz at the end of first module or second module. What I have decided is my class has to be very interactive. Okay. Say for example, I'm doing some derivation and I'm solving some numerical. Maybe half of the problem I'll solve. The remaining part I'll leave it for you people. Okay. You have to sit and solve the numerical along with me. And during the class, I can unmute any person. I can ask them to tell me the answer. So my answer and their answer must match. So for that to happen, you have to be regular to the classes. You should be listening to the classes. It's not like your system is there and you are disappeared. Okay. So I don't want that. The class has to be really interactive. And at the same time, when I'm teaching something, maybe in between I'll unmute somebody and I can start asking the question. So whenever I'm asking any question and people are answering me correctly, I'm going to make a note of that. And later that will be considered for the quiz. Okay, so separately I am not going to give any quiz. Whenever, wherever in the class possible, I'll be asking the question. Whoever answers correctly, that person will be getting the marks. I'll be making a note of that. That is coming to the class. Okay, and second thing, coming to the attendance. I don't want anybody to post their attendance in the chat, or I will not take the screenshot of the participant, because I know what happens in online classes. Only my video is on, other side the video is off. So the student might turn on the system and he may go away. Okay, by just looking at the participant list, I will think that the person is there. So I don't want to have that kind of false information. So like how we used to take the attendance in a regular class, the same way I'm going to take the attendance. So the condition is, whenever I'm taking the attendance, that particular person for a fraction of second, they have to turn their camera video on and they have to answer. It's not like video is off and saying yes ma'am, no. I want to see your face and then take the attendance. Okay, so these are my requirements. You have to be regular to the classes. Whenever I'm doing the problems or the derivation, you have to take along with me, and in between I'll be asking the question. People, they have to on the video and they have to answer me. Similarly, attendance. Whenever I'm taking the attendance, they have to on the video for a moment and then they have to answer the attendance. It's not like beginning I'm entering the class, I'll take the attendance. It's left to me. Maybe after 10 minutes or maybe after half an hour or maybe at the end of the class, I may take the attendance. It is just to know that the students are there and they are regular and they are attending for that purpose. I don't know about the other subject, but these are the requirements for my subject. Because as I told you, it's a completely numerical subject. Until unless you are regular to the classes, you are working along with me, it is not possible from your side to understand. Okay, so you have to have the help of a teacher. If people are managing on their own, it's really good, but what I feel is you must have the help of a teacher. So make sure that you are attending regularly, you are with me, and any doubt, anything you can ask in the class, you can on your video and you can ask in the class itself. Okay, and latecomers are not allowed. If the class is at 1 o'clock, make sure that 1 o'clock you log in. Don't come 5 minutes, 10 minutes late, because I was waiting. 1 o'clock class was supposed to start, still people were entering, and till now I think only 66 participants are there. The remaining 74. Okay, others I don't know what happened. Okay, fine. Okay. Then I just want to share you the COs of the subject. So each and every student is supposed to know what is the CO, that is the course outcome of the subject. So we have defined four COs, that is course outcome, that is after learning this particular subject, what you're going to achieve. So the first CO, it deals with the acquiring the knowledge of basic concepts of electric and magnetic field. As you have seen the first chapter, it completely deals with Coulomb's law, the electric field, the electric flux density, okay, how we calculate the fields of a point charge or maybe a line charge or a volume of charges. And the second CO we have is interpreting the laws and theorems of electric and magnetic field. Like we have seen, we have Gauss law, divergence theorem, Stokes theorem. These are the important laws of the theorems which are associated with various electric and magnetic fields. And then we have CO3, which says apply the knowledge of fields on various electric and electronic system. I gave you the example of a coaxial cable, right? So coaxial cable, it's one kind of, I can say, a component where whenever the current is flowing through, some sort of fields are associated with that. So if you have the knowledge of the fields and how to represent them in various coordinate system, you will be able to calculate the fields associated with them. And then CO4, we have understanding the concept of wave propagation. As I told you, module 5, it covers the propagation of the plane wave. Like how, what happens to the waves, what are the losses associated whenever they are propagating through different mediums, or what kind of impedance they offer when they are propagating through different medium. Okay. And these are a few formulas which I have noted down here. As I told you, you should have a good knowledge of integration and differentiation. Make sure that somewhere in the notebook at the last page, you make a note of all these formulas, and at the same time the right angle triangle, because very essential. Most of the problem we make use of this concept of right angle triangle in order to calculate the various angles, theta, phi, so and so for different coordinate systems. And now coming back to the introduction part, as I told you, electromagnetic waves basically deals with the study of charges which are at rest as well as charges which are in motion. So whenever the charges are at rest, it gives rise to an electric field, and whenever the charges are in motion, it gives rise to a magnetic field. And some special case, who is that? Please mute yourself. Guys, please mute yourself. Don't disturb me or others. Then we have two more important topics. Electrostatics basically deals with the charges which are at rest or stationary. And then we have magnetostatics, which basically deals with the charges which are in motion. Together, I can say electromagnetic waves are the waves which are excited by the charges when they are propagating with respect to time. Time varying motion in the sense when they are traveling or propagating with respect to time. And one more important fundamental, this electrostatics, I can say it is the physics term which has come from static charges. As you all know, electro means charge and static means which is stationary and that which is not moving. And as you all know, charges are of two types, positive and negative. And what are the losses of these charges, positive and negative charges? As you all know, the positive charge and the negative charge repel each other, whereas positive and negative charge attract each other. Okay. Sorry, today I'm actually working from home, so I'm taking the class from home. From tomorrow onwards, I'll be in college, and wherein I'll be going to the classroom, I'll be using the blackboard in order to take the class. That's why I requested you, people should have a new notebook. So whenever I'm writing some definitions or derivation, make a note of that. So be with me. Okay.